Good afternoon, ladies and gentlemen. It's my personal privilege to welcome you all for this distinguished lecture series. We have the privilege of Mr. Padu S. Padmanaban, former Program Director, SARI, and Senior Energy Advisor, USAID, to be here with us to deliver the distinguished lecture. Mr. Padmanaban, Padu as we call him, is a renowned expert on energy efficiency and allied areas and has played a very important role in accelerating energy efficiency in India through his services and expertise. He's one of the very few persons who have contributed significantly to the energy efficiency movement of the country. He has more than 4 decades of experience in designing of national and regional energy efficiency programs. He has contributed significantly to the power sector reforms and regional energy integration in South Asia, contributed to development of energy water nexus programs, clean energy and energy access projects, substantial contribution to planning and establishment of national and regional centers of excellence in energy efficiency and green. We from the Green Business Center have the privilege of Mr. Padmanaban guiding us in the initial stages of the formation of the Green Business Center. He served as the program director for South Asia Regional Initiative of Energy and senior energy advisor for USAID India's bilateral program. He's worked with several national and international agencies such as the World Bank, CAPSARC, AEEE, Altec Foundation, and several of them. Padu, for his leadership and contribution, has been recognized both at the national and international level. Padu was recognized as the Regional Energy Manager of the Year 2019 by the United States Association of Energy Engineers. The IGBC had the privilege of having Padu receive the Hall of Fame Award in the year 2013. The World Clean Energy Award 2007 by the Swiss-based Transatlantic was given to him in recognition of his achievements in advancing energy efficiency and renewable energy. He also received the All India Power Award in 2010, the Energy Professional Development Award in 2008 by the Association of Energy Engineers India. Padu has been a felicitous speaker. He has taught at the School of Advanced International Studies, Johns Hopkins University, Washington, D.C. Padu has a bachelor degree in engineering from University of Madras and a postgraduate certificate in fuel efficiency from National Productivity Council India and diplomas in energy management from UCTI IRI Rome and ILO Torino. Apart from all of this, Padu has been a thought leader in energy efficiency and several of those related areas, an extraordinary communicator. Apart from thought leadership and communication, Padu also has a very unique capability of converting all his thoughts into action and in a very collaborative manner. We have had the privilege of enjoying the leadership and guidance of Mr. Padmanaban in the establishment of Green Business Center. Thank you, Padu, for being here with us to deliver this distinguished lecture. It's over to you. Thank you very much.
Good evening. I would like to thank CIIGBC for this opportunity and invite me, and especially thank my good friend Venkatagiri for his warm words of welcome and introduction. You really made me blush, Giri. Thank you very much. I am deeply aware that I am in a forum which has had renowned speakers in the past, people, a galaxy of speakers of eminence. And I'm both humbled and privileged to be part of that group. Given that the audience for this particular webinar is from industry, I thought I should focus on issues related to energy efficiency in Indian industry and what is next. That said, I would really like to begin with a historical context, the genesis of energy efficiency in India. Energy efficiency in India was actually led by the Indian corporate sector. It was way back in the mid-60s when in Mumbai, the textile industry had a problem. They used coal, and coal has required a lot of space. So there was a premium on space in Bombay, shortage of space then, now for sure. And much of the coal, or in fact, all the coal was coming in by wagons from Bengal, Bihar. And there was a limitations on the number of wagons available. And that apart, the rail wagons had to negotiate the steep incline of the Western Ghats, and there used to be occasional accidents. And all of this actually proved to be a bit of a dampener in the receipt of coal by the city textile mills. And the textile mills were in a quandary and were looking for solutions. Around the same time, there were the two refineries in Mumbai, Escos and Burma Shell, and both these refineries had excess fuel oil. These are the heavy bottoms, and they had excess of it, and they wanted to market it. And what better than to market it to the textile industries who were their neighbors in Mumbai? But there was an issue here. At that time, in the early 60s, Indian industry had very little experience in the use of fuel oil. The preparation, the storage, the handling, and the combustion of fuel oil was something that Indian industry did not have much experience with. So the Planning Commission of India, when they were seized of this problem, they approached NIFES, the National Institute of Fuel Efficiency Services of UK, and inquired whether they could help them in advising Indian industry, particularly textile industry, on fuel efficiency and how to use fuel oil. The NIFES team visited India. They partnered with the National Productivity Council. They helped establish a fuel efficiency service within the National Productivity Council, and the NPC, together with the oil companies, began to provide the service to the textile industry in Mumbai and later expanded it beyond Mumbai. In 1973, when the oil price hike took place, the NPC's experience in fuel efficiency came in handy, and together with Indian Oil and Bharat Petroleum and Hindustan Petroleum, they provided fuel efficiency services to Indian industry at large. And this particular effort by these entities resulted in 1976 setting up of the Petroleum Conservation Research Association, or PCRA, who until even today provide petroleum conservation, strategic advice and services to the Indian economy. So between the periods between 1970 to 1990, the 2-decade period, terminologies changed. From fuel efficiency, we moved to energy conservation, to now energy efficiency. There was this 1982, there was this interministerial working group report on energy conservation in Indian industry, policies and programs. It's a very strategic report which provided a blueprint for how Indian industry could save energy. So during this 2-decade-long period, several lessons were learned, but there were two very important lessons. The first lesson was the establishment of fuel efficiency cells in industry, that is institutionalizing fuel efficiency or energy efficiency within an industrial complex. And this was done in a few industries, not very many, but at least a few stepped up to the plate and set up these fuel efficiency establishments within the premises. Hindustan Antibiotics, Hindustan Levers, Century Rounds, these were some of the companies who did so. And many of these companies also saved a significant amount of fuel oil. 20 to 30% fuel oil savings was registered. The other lesson was that energy audits began to be in fashion. In fact, Indian industry actually took to energy audits like a duck takes to water. And energy audits became quite popular, and the energy audit function also grew. But there were some mixed blessings in that, because as we all know, energy audit is not a destination, it's only a way station. It identifies energy efficiency measures, does not guarantee that they would be implemented. For implementation, you need a measurement and verification system, a before and an after. Energy efficiency cannot be metered. It can only be computed, for which you need a before and an after. You need an M&V system. And the discipline of measurement and verification took a while for it to develop. In fact, it did not develop in complement with the energy audit function. So there were some bumps along the way. But notwithstanding these bumps, we are today in 2021 at a fork in the road. And there are a couple of important questions that we need to ask. And there are specifically 3 issues which concern energy efficiency today. And they are, is it time now to reimagine energy efficiency and replace it with another coinage? As I said earlier, from fuel efficiency, we moved to energy conservation, to energy efficiency, and now is it time to move to another coinage? If so, what is that? The second issue or factor is it time to tap the core benefits of energy efficiency and use it to provide the persuasive arguments to press corporates and government to do more on efficiency? And the third is, how do we move from a unidirectional linear approach in the design of efficiency projects to a more integrated approach that can save 20 to 30% more fuel at the shop floor level? So these 3 issues or questions is what I would like to unpack with some solutions and answers. The first one is on reimagine energy efficiency. I would like to rephrase the question. Generally, we ask this question, how is energy used in industry? And the answer is pretty straightforward. You do an energy audit, you identify conservation opportunities, you rank the conservation opportunities, implement the measures, you save energy, end of story. Now, if you rephrase the question and ask the question, what is the energy used for? This is a very intricate question. It's not that simple to answer. What is the energy used for? And this question is important because what value addition can energy contribute to your enterprise? By switching from how energy is used to what is it used for, the goalpost has shifted. When you talk about the question of what energy is used for, then the answer lies in a different nomenclature. And this nomenclature is energy productivity. Now, energy productivity is the measure of economic growth or economic value from each unit of energy consumed either by a company or by the country. At the country level, it is defined as the GDP divided by every unit by the total energy consumed by the country. At the company level, it is the revenue of the company divided by the energy consumed annually. And both the definition of energy productivity for a country, whether it's for a company or a country, requires an understanding of what it means vis-a-vis energy efficiency. Now, energy productivity, by the very definition and how I defined it, is focused on value addition. It is focused on value creation. Energy efficiency, on the other hand, focuses on energy savings. Energy productivity is strategic. and seeks answers through modernization, diversification, and restructuring. Energy efficiency, on the other hand, is a tactical bottom line issue and contributes to cost reduction. Energy productivity, on the other hand, is a top line investment issue and directly contributes to revenues and profits. The challenge for Indian industry and for corporates is to transit from energy efficiency at the shop floor level to value creation through energy productivity at the board level. You need an industrial strategy that moves you from producing basic energy intensive products such as aluminum or steel or paper to high value products. For example, you move from aluminum ingots to manufacture of fuselages made of aluminum. You move from mild steel to manufacture of alloy steel, which is used in precision machine tools. You move from stationery paper to high quality paper, and so on and so forth. And there are examples in this country where this has been done. There was a paper mill in East India which was manufacturing stationery paper, and they moved to high specialty paper, and they improved the value addition threefold. There is this example of cement industry, which was making pozzolana cement and moved to high specialty cement with much higher value addition. There's a petrochemical plant which manufactured nylon from caprolactam, but moved to high industrial fibers and high value items. So there are many such examples. Also, if you look at India, energy intensity in the industrial sector by and large is declining, is improving. So if that's happening in India and as also in other countries, so what's the problem? If you look at the G7 countries, especially the United States or Germany or France or Japan, here you would find that GDP per unit of energy has increased. GDP has increased, energy demand has declined or reduced in absolute terms. There's been an absolute decoupling of energy growth and GDP. In India too, GDP has increased, but energy consumption has increased, but the rate of increase of energy consumption has reduced. In India, it is not absolute decoupling, it is relative decoupling. Now we need to move from relative decoupling to absolute decoupling. We need a paradigm shift in how we view energy efficiency. Now, just bear with me for a few statistics. Between 1990 and 2015, in India, energy productivity improved by 78%. During the same period in China, it improved by 203%. Now, it's important to understand that the Chinese improvement in energy productivity was due to structural changes and value addition largely, and to some extent was based on shop floor energy efficiency. In India, on the other hand, much of the energy productivity improvement, although far less than what China had done, was largely due to industrial energy efficiency and to some extent due to structural changes. In fact, in India, our energy intensity on a year-by-year basis between 1990 to 2015 reduced by 1.8% every year. And energy intensity is the inverse of energy productivity. So energy productivity improved by 1.8% per year. But in China, energy intensity reduced by 5% every year, the largest reduction in energy intensity anywhere in the world, and much of it was due to structural changes. Now, that is important to note. Well, ours reduction was due to energy efficiency, but improvement in energy efficiency improves energy productivity, but only improves energy productivity marginally. That's very important to note. Improvement in energy efficiency improves energy productivity, but improves energy productivity marginally. The major improvement in energy productivity would be through structural changes and value addition, and the points that I made earlier. Now, this cannot happen overnight. The Atmanirbhar Bharat strategy for innovation in manufacturing to self-reliance and make in India is a step in that direction, could be a step forward. So this is the first point I wanted to make, that energy productivity is an important element and strategy to advance energy efficiency in the country. The second point is with respect to integrative energy efficiency. I've had several discussions with captains of Indian industry, and they have often wondered if they have achieved the full savings potential of the energy efficiency interventions and investments. The basic question is, can you save more energy than what you have designed your system for? Besides OPEX, can you save CAPEX? Besides bottom line operational savings, is it possible to simultaneously achieve top line investment or CAPEX savings? Now, if you were to map energy efficiency technologies and energy efficiency opportunities, you would have 4 quadrants. Quadrant 1 is well known. It is first aid measures, housekeeping measures, and I'm not going to talk any more about it because Indian industry is very, very familiar with that. Quadrant 2 is what I like to call as must-dos. These are energy efficiency measures. They are isolated measures such as waste heat recovery or combustion control or steam utilization and distribution efficiency or insulation. So these are specific standalone energy efficiency measures. And Indian industry has done quite a bit in that, and that's where Indian industry has largely been focused on. Quadrant 3 is integrative energy efficiency design approaches, and I'll come to that in a moment. And quadrant 4 is transformative technologies such as circular economy, digital manufacturing, nanotechnology, and so on. And quadrant 4 is still a little long term. It's not something that's going to happen now in the short and medium term. But quadrant 3 is where Indian industry is moving towards. In fact, is knocking on the doors of quadrant 3 and getting into integrative energy designs. What is integrative energy designs? It is advanced heat power cycles, cogeneration systems, pinch point analysis in chemical process industry, integration of pumping systems, and so on and so forth. There are water energy nexus kind of projects and so on and so forth. So that's where the Indian industry is moving towards. While quadrant 2, where they have all the experience, is energy efficiency projects structured around individual technologies. Quadrant 4 is, rather, let me step back from it. Quadrant 2 is individual technologies, but they do not include design methods that are inclusive. This is a very serious limitation in my mind on current energy efficiency design approaches, where diminishing returns limit us. What does this mean? It basically means, and I'm wearing my economist hat for a moment here, it basically means that when the marginal cost of an energy efficiency investment is greater than the value of the next incremental investment or next incremental savings, we stop, since we do not want to cross the cost competitiveness limit. It makes no further sense to tap further energy savings because it is not cost effective. But integrative energy design enables us to expand upon energy saving by another 15 to 30% more at a lower marginal cost of incremental investment and savings. The design approach is to tunnel through the cost effectiveness limit. Now, let me give an example. I mean, that will be easier to understand. Let's talk about a simple example which we in industry are familiar with, pipe insulation, steam pipe insulation. We know about minimum economic thickness of insulating wool. That's fine. But what about the rest of the system? The moment you reduce heat losses in pipelines, and assuming this is a very large chemical process plant and the steam losses are reduced, heat losses are reduced, you can trace it back to the boiler because you would have a reduction in the MCR of the boiler, the maximum continuous rating of the boiler. You will have a reduced size of the ID fan and the FD fan. In fact, the whole generating system would be downsized. Now, that's where you get your CapEx savings. That's where you get some of your energy savings too. The important point is that you don't select your generating system before you design your pipelines and your insulation. That's done first, and then later you trace it back to your boiler and all of that and downsize it accordingly. Let me give you another example. Big pipes, small pumps, or small pipes, big pumps. What do I mean by small pipes, big pumps? Generally in industry, the pipes diameter, if it is small, the friction losses are higher, the head losses are higher, the pump capacity to overcome those losses are greater, and hence you have a higher horsepower pump for a certain flow of fluid. Now, if you were to have a generous pipe, a larger pipe, then obviously you're going to have lesser head loss and lesser friction loss, and therefore your horsepower of the pump can reduce. So that's what I meant by big pipes, small pumps. Or if you don't do that, you have small pipes and you have big pumps. But the lesson here is, and I'm just giving it as a principle, the lesson here is that you do your pipeline design before you select your pumps. There are many, many examples of this kind. Let's look at a lighting example. You have, there's a lot of effort being spent in identifying a light source with the highest lumen efficacy. LEDs are an example. But when you really look at it, it's the task efficacy and the application efficacy which is as important as the lumen, the efficacy of the lamp and the fixture. In fact, you can have a high efficacy lamp and have a poor application efficacy, that is, the light doesn't reach the task needed to be lit up, and you'll have an overall inefficiency of the system. So clearly, you have to look at not only selecting of the right lamp, but also ensuring that the light from the fixture is used to light up the task required. So these are minor examples, but important that they are. Another way of looking at it is what I would call as the drill and hole analogy. We spend a lot of time in selecting a drill and selecting a drill bit, but spend very little time in identifying where do we want to put the hole, what should be the size of the hole, what should be the diameter of the hole, what should be the depth of the hole. And it's important really to understand that you have to look at things in a more integrated manner. The bottom line is that integrative design optimizes the entire system as a whole instead of its part in isolation. And in the process, could save you 10 to 30% more energy. Now I come to my last point. The last point, if you recall, I said that we need to look at the core benefits of energy efficiency. We need to look at energy efficiency not simply in terms of energy saved, but as the number of core benefits realized. This has been recognized in the building sector, and CIIGBC is very active in the building sector, and they know that. There is a strong empirical connection between energy efficiency and indoor air quality. There are positive impacts on health because of energy efficiency, because of improved indoor air quality. There are positive impacts on labor productivity. There's even some impact on absenteeism, that people like to be in the office and don't absent themselves from work. The corporate decisions on green buildings has changed. They no longer look at energy and water savings as the basis to go in for a green building. Some of these core benefits and the advantages thereof. But industry, by and large, has not recognized these core benefits to the extent necessary. One benefit which occurs every time efficiency measures are introduced at the shop floor level, particularly in engineering plants, is product quality. Product quality improves tremendously. There's improvement in employee motivation, employee morale, in industrial safety, and industrial hygiene, and so on and so forth. But there's also a macro level aspect to what I'm saying. And this is extremely important. It doesn't cover the industrial sector, but it's an important fact that there are macroeconomic benefits of energy efficiency beyond energy savings. And one of it is it can actually be a powerful tool to reduce the fiscal deficit of a state. I don't want to digress too much into this, excepting to state that power supply to agriculture in the country requires subsidization of the power. Farmers pay a subsidized power. And the subsidy is paid for or covered by the exchequer through a direct subsidy to the utility. And this contributes to some extent to the fiscal deficit of some of the large agricultural states in the country. 10 to 15% of the fiscal deficit can be on account of the direct subsidy paid for by the government to the utilities for the losses suffered in not getting the right prices from the farmers. So every unit of energy saved in agriculture through energy efficiency measures of pump sets and T&D loss reduction and so on and so forth can actually contribute to reducing the overall subsidy and therefore reducing the fiscal deficit. And more money now can be made available not to cover the losses in the power sector, but to the other social sectors like health and so on and so forth. So this was the third point I would like to make. Coming back, and I think I'm coming very close to my end, because I was told I have not spent more than half an hour. But in conclusion, climate change is a very difficult, dangerous, intractable, and existential threat to our country, to the world at large. And we all know the reasons for climate change. It's largely because of the carbon emissions which have taken place. And today, the world is moving towards, at least some of the countries are talking seriously about net zero buildings, net zero manufacture, and so on and so forth. If India is to move towards net zero, assuming you have a net zero India kind of a strategy, then energy efficiency has to be front and center of it. Clearly, energy efficiency is the bridge between a society or a country dominated by fossil energy as it moves towards economy dominated by renewable energy. Energy efficiency has to be the bridge. In fact, it has to be the first fuel. But for energy efficiency to be the first fuel, it is my contention that we need to look at reimagining energy efficiency as an energy productivity strategy. We need to tap into the core benefits of energy efficiency more than we have done so. An industry certainly can draw a lesson from the building sector in that. And we need to introduce integrative energy efficiency programs and approaches as against standalone energy efficiency measures that we have done so far, so that the system efficiency can improve and we can save 20 to 30% more energy than what we are now achieving. So with this, I will conclude. Thank you very much. Look forward to.
Thanks, Padu. Thanks for your address. I think you covered all the three areas very clearly with examples on the coinage of energy efficiency, moving towards productivity, the co-benefits of energy efficiency, as well as looking at an integrated efficiency program rather than standalone programs. Thank you. Thanks for your address, Padu. Participants, please type in your questions on the Q&A and the chat window. We will compile it and request Padu for his responses. Padu, there are already quite a few questions that have come in. I'll start with some of the questions, and then maybe as the questions come along, I'll take them. There have been quite a few questions in terms of what you see as the next three big things as far as energy efficiency in India is concerned. I mean, you mentioned about how the shift has to happen. But if we are looking at certain strategic areas in terms of the big movement, will it be towards renewables that you see, or will it be on Industry 4.0? Is that something that we see as a big enabler as far as accelerating energy efficiency is concerned? What are the three big next things that you see on energy efficiency?
That's a good question, and I see. That energy efficiency would be mainstream more than it has, and it will largely happen due to the introduction of advanced data analytics. I think data analytics will play a key role in corporate management to manage the energy systems better. And in this context, cloud computing, as well as advanced instrumentation, IoT, and so on, would play a very, very important role in advancing energy. The second is both renewables and efficiency are two sides of the same coin. You cannot move forward on renewables if you don't have an energy efficiency framework in place. Otherwise, renewables gets pretty costly. The third thing, which I think would happen, and this would happen through government policies and standards and so on and so forth, would be that there would be a much more enhanced implementation of energy efficiency through advanced energy management systems. So I see energy management systems progressing to a point where one would have remote control and IoT and all of that. I see major improvements in energy audit function. And I would see actually the MNV system, and this is, I think, important. Measurement and verification would now become center stage in an energy efficiency program. You see, as I mentioned earlier, energy audits in India have progressed and have become more sophisticated, and that is good. But an audit by itself is not sufficient to realize energy savings. It only identifies opportunities. you need to complement it with the MNB system. So I see MNB systems as developing on a real-time basis. So that's another thing I see.
Thanks, Padu. Moving from energy audit to M&V, I think the key player there could also be an Esco. There are a few questions on what you think could be the role of Escos in accelerating energy efficiency in the country. Again, a subject which has been discussed at length. What are the next things that we should do to get more vibrant Esco market in India?
Well, this has been a subject which has been studied quite a bit, and actually it's been a bit of a disappointment that Escos have not really been the promise that we thought that they would. And there are some good reasons for this. One is the standardization of the approach, I think is important. The second is the second reason is that Indian industry has been reluctant to transfer responsibility for its energy savings to third parties. They like to do much of it themselves. That hasn't really changed. So there has to be an attitudinal shift in the minds of industries, end users, that an Esco is an equal partner, and an Esco would actually save energy, but in a very collaborative way. The question of financing, I think, continues coming up, but I think that problem, by and large, is now being addressed through different commercial arrangements, guarantee payments, and so on. So I think would be, by and large, addressed for good projects. But the attitudinal changes, I think, has to be made, and that hasn't happened to the extent that we thought that it would. The understanding of how an Esco operates and the associated with the investments made, all some of the issues that I think needs to be addressed in parallel.
Thanks, Padu. The next question is on finance and access to finance for energy efficiency projects. While most of the projects today are being implemented through internal funds, how could we look at a structured, more dynamic funding mechanism for energy efficiency projects in the country? How can we get technological projects be made more available and accessible with financing? And lastly, any innovative financing models that you think should come in the country that makes this more accessible for all the players?
Well, see, this is a very interesting question because, again, it has been addressed at various points of time. Largely, when you look at energy efficiency as a bottom line kind of a measure, much of the investments really are from the company's own balance book. They generally use their own resources to implement the measures because number one is it's well within the control, and number two, the cost of the measure may not be unduly high. But when you start looking at energy efficiency in a broader context, modernization and diversification in order to advance energy productivity, then the resources required to do it will be far greater. And this is where one would like to look at financing to access the technologies which would be required. So in that context, I see when energy efficiency expands beyond being a bottom line kind of an investment through a productivity approach, I do see innovative financing coming through capital markets. Very few industries, I can't recall any industry accessing capital markets for energy efficiency programs, but they do access capital markets for energy productivity programs, or modernization programs. And in that context, I see that as a very innovative measure that could happen. And indeed, if that happens, then I'm sure efficiency will speed up.
Thanks, Padu. Thanks. One of the question was to say that, I mean, well, a large amount of our discussions have been around the heavy manufacturing industries, the larger industries. What are your thoughts on energy efficiency in small and medium enterprises? Somebody who has the need for both access to technology, access to finance, access to capability. I mean, what kind of programs should we look at for improving efficiency in the small and medium enterprises?
You see, the Indian industry, the large industries have done well, I should say. You have examples of cement industry, which all of us are familiar with, which is best in. You have examples of paper industry, which have now improved the efficiency parameters, and you have steel industry and so on and so forth. So Indian industry has by and large been able to address some of the technological needs for efficiency, strategy and program. But it is the small and medium scale industry where opportunities are great. The importance of energy efficiency hasn't been given that amount of rigor. And that's where one needs to focus on. And the points you mentioned about access to finance, access to technology, the standardized use of equipment, etc., are some other barriers to small and medium scale industry. But having said that, it's very important that the approach to the small and medium scale industry is done a little differently. Small and medium scale industry has certain issues and problems vis-a-vis the scale at which they operate. They have problems related to a theoretical solution. They need to be advised less and demonstrated more. So we need to have more pilot projects, more demonstration, because that is what would convince their managements to go in for an efficiency kind of a program. So it's a very different approach that one would follow. You know, human capacity in small and medium scale industry is meager. They need to be trained, and they need to be handheld. And there is a package of measures that is required, right from accessing finance, which you rightly said, to demonstrating the technology, which is extremely important, and then working with them through the implementation of the technology or of the process in the facility. Also, small and medium scale industry clusters, so it's possible to work with some of the champions in the clusters and then through them reach out to the others. So there are various ways of approaching it. And there's been a fair amount of thinking going on as to how to deal with this. And I think the next big challenge for India, in fact, it's a continual challenge for the last few years and will be for the next few years, is how do we open the small and medium scale industry in addressing the energy efficiency opportunities which are there for the taking.
Thanks, Padu. The next question is on, I mean, this comes from our viewers on Facebook. The question is, how do you see the water energy nexus play out, especially with agriculture sector having a big role in this, and more so with the energy crops, which have an active role on the ethanol blending program, which the government is looking at, but are also very intense on their water requirements.
Well, the water energy nexus plays itself off in the agricultural sector, but I would not get into it because that will take me away from the subject at hand. But it plays itself off very well also in the industrial sector. You need water energy, you need energy for water, as they say. And in the industrial sector, at least 20 to 30% of energy in chemical process industry is in one way or the other related to water in one way or the other. You need to pump the water, you need to treat the water, you need to convert the water into steam, and so on and so forth. So there's a fair amount of energy there. If one were to look at water and energy separately, then I'm afraid that you will not make use of the integrated design opportunities possible when one were to kind of look at both of them holistically. By holistically, I mean water management, water conservation, recycling of water, and all of that has impact on energy consumption. In passing, I mentioned that cooling towers will make a very important contribution to energy efficiency and conservation, as well as improve the water conservation opportunities. So there are different technologies. Today, in textile manufacturing, textile dyeing, for instance, there are technologies where you don't need to use any water at all. It can all be done through foam technology and so on. In paper manufacture, there are technologies where one can use different heat sources other than steam to dry paper, manufacture paper. So we have to look at water conservation technologies, have a very important energy addition to it. Energy requirement would also reduce. So water energy nexus plays a role, as I said, in the industrial sector. The point that the savings in energy would be large. Last point on this. In California, I was told that a program for the water energy nexus in Californian industries saved more energy all the other energy efficiency programs in the state. That is the extent of potential possible if one were to look at water and energy in a co-management kind of an approach and use technologies which conserve water as well as conserve energy at the same time.
Thanks, Padu. Another interesting question, which is kind of dwelling on the energy productivity part. The question goes like this, Padu. I am an energy manager of my organization. How do I contribute to improving and enhancing the energy productivity? It looks like a very high level test. What can I do on the ground to help my organization improve its energy productivity?
That's an excellent question, and that's the right question to ask. Because how can a person shop floor level look at issues which are really something which he or she does not control? As I said, energy productivity is a top management boardroom concept. It is not as though that energy efficiency is apart from energy productivity. Energy efficiency is a subset of energy productivity. So we have to bear that in mind. Point number 2 is, as you plan your plant expansion and so on, you would find that there are areas where one could intervene or at least advise management as to alternate technologies, new markets for diversification, new products for value addition, and so on. So if, for instance, you're making glass and you understand all about glass furnaces, you could also weigh in and find out whether certain types of glass we manufacture have a higher value addition, that the net energy input, the company gets a higher revenue, and that's what energy productivity is all about. Energy productivity enables shop floor people to look beyond the shop floor and to look at options, opportunities in the marketplace where their company can play a role. It is diversification, where every unit of energy brings into value. So when you start looking at my energy is used for, rather than how energy is used. Of course, how energy is used is energy efficiency. I mean, we have talked about it. But what the energy is used, then you'll be able to see the opportunities that lie in your own factory processes for manufacture of high value added items. So that's a boardroom subject, no doubt, but shop floor people and managers in the factory put their mind to it. And that's how, decisions are finally made. I hope I have answered it, because I have a ready solution to it. All I'm saying is you've got to expand your mind to think about energy productivity. It's a different challenge altogether.
Thanks, Padu. The next question is on data on energy efficiency. I mean, as you mentioned,
can you repeat that?
The data, the data of the activities and processes that are happening around energy efficiency. We have traveled a long way. I mean, what are the next things that we see as far as understanding from what has happened in the country, identifying where we are, where the gaps are, and how can we move forward? How do we compile all the work that has been done on energy efficiency into something where we are able to visualize, identify the opportunities, and move ahead?
That's again an interesting question, because everything depends on data, and when you get good data, you can then develop important parameters, and then you can develop your design so as to meet certain performance levels. To my mind, since this question is more of a policy question, to my mind, I think we need a centralized energy efficiency database in the country. And this database is not something that you do in isolation from industrial processes, but you do it in partnership with industry. And how it will work is that at an industry level, we need to come out with highly effective but low cost energy information management accounting systems, or EMAS. These are nothing but energy metering systems, energy instrumentation, which will be able to be put in a factory or shop floor situation, and will track both energy as well as production, and come out with a whole lot of parameters of energy consumed per unit of product manufactured, and so on and so forth. It's much more complex than what I'm saying, but I hope you understand what I mean, that one can have instrumentation of energy parameters in a factory and come out with all these kind of relationships of energy consumed per unit of production in different departments, etc. But this EMAS system will be that. It will be the intelligence to do so. And EMAS of different companies, fully safeguarding the anonymity of the company, can then feed into a centralized database and come out with a centralized. This whole system needs to be kind of developed on a real-time basis. Now, once you do that, you have the following advantages. You'll be able to do gap analysis very quickly. Both the industry can do gap analysis as to how they compare with their neighbors, how they compare with similar industries in India, abroad, where are the gaps and how I can reduce the gaps. I think that is extremely important information. And the gap analysis would be the basis to move forward with an energy technology, efficiency technology program. That if there's a gap analysis says that these type of technologies are non-existent and not being used, then one can focus on it. For policymakers, it's valuable. So that's where my answer would be, that we need to move towards advanced data analytics, which will enable us to do all the things that I just mentioned.
Thanks, Padu. The last question which I had was on policy, and you touched upon one of the policy that you would like to look at is on data. The question was to look at what are the 3 or 4 key policy changes that you think we as a country should look at to kind of accelerate the energy efficiency agenda, both at industrial and at all stakeholder groups.
Well, the policy issues have been discussed in the past, and what I'm going to suggest is not anything different, excepting that we need to take it all to its logical conclusion. What we need is, and here I'm trying to think out of the box, and we can talk about policies as far as standards are concerned, labeling is concerned, mandatory energy audits are concerned, and all of that is fine and they're necessary, and we need to do a lot of them. But what we need to do is enunciate energy efficiency principles in every sector of the Indian economy. What that means is that any activity, if you can think of, has an energy implication. Whether you're building a bridge, or building a school, you're operating a transport company, you're operating a municipality, everything has an energy implication and an energy connotation and an energy penalty if you do it wrong. So we need to come out with these principles of energy efficiency, which then needs to be followed through by the subsector concerned very faithfully. And these are not principles in isolation, but these are principles which can really help in guiding that particular entity. So once, like for instance, you have a municipal pumping system, water supply system. There are huge energy implications if you take the wrong decisions. So whether one can bring in certain principles of operating of these systems in a way which is in tandem with the load profile of the utilities or load objectives of the utility. Now, this is something which doesn't happen in this country as often as it ought to. You have, the sewage and water board of many of our cities working in complete isolation from the electrical network, in the sense that they operate at a time when they could actually contribute to peak load management. So, if you understand what I mean, the connotation on energy in every end use can be brought to the fore through these principles, and these principles will aim at reducing energy consumption. And that's exactly how the green building movement internationally took place. If you recall, it is the Hanover principle, I think in the 80s, which came out with certain principles for buildings. And this Hanover principle was then adopted by the US Green Building Council to develop their green building strategy. And then that spread from there. So similarly, I think we need certain energy efficiency principles for different subsectors, which then can be used as lodestones or guidance for that sector to take the right decisions. This has not been talked up sufficiently. I mean, we talk about efficiency in terms of all audits and mandatory stuff and all of that, but the next step forward and come out with.
Thanks for the excellent thought. I think looking at energy efficiency in all facets, every decision making of every activity of the state and the central governments, I think that cuts across the entire activity profile. Thanks a lot, Padu. Thanks for your excellent address today. I think we learned a lot from your address. We learned much more during the interactions from the responses that you had for all the questions that came in. Thanks a lot. Thanks for your address today. And
thank you very much.
Thank you. And to all the participants, the video recording will be available. It will be shared with you both on our LinkedIn and Facebook pages. It will be available on our YouTube link as well. So please do feel free to share it across to all the participants whom you feel have missed the session and would benefit from the discussion. Thanks again, Padu. Thanks for your session today. Thanks a lot.
Moderation, Kiran, and thank you, Giri, once again for your warm words of welcome. Thank you very much.
Thank you, Padu. Thank you.